Okay. I'd like to welcome everybody in attendance for this month's webinar, and thank you for joining. My name is Matt Romoger. I'm a swine field specialist in Southeast Iowa. And today we've got a very timely talk, I feel like, as we've got warmer weather certainly on the horizon. Feels so much so today and then in the coming months. So joining us today, we're going to have Dr. Brett Ramirez talking about how to prep your barn for summer and putting checklists into practice. A little bit about Brett. Dr. Ramirez is an associate professor in the Department of Agriculture and Biosystems Engineering and interim director of the Egg Industry Center. Dr. Ramirez's expertise lies in livestock and poultry housing facilities, focusing on environmental control by means of ventilation, air quality, and climate control, specifically thermoregulation. His research and leadership contributes significantly to the advancement of sustainable agricultural practices. So thank you, Brett, for joining us. Just a few notes for attendees. If you've got questions throughout the presentation, feel free to put them into the chat, and we will go over those at the end. So chat would be in the bottom right corner of your screen, so feel free at any time to go ahead and submit questions in through that. Also, if there's anything you want to review back on this webinar, if you found a piece of information valuable and you want to be able to go back and refer to it later, you'll be able to find this recording posted to the Iowa Pork Industry Center YouTube page, along with other past webinars. So certainly a good resource to go and look up after the fact if you feel you want to review any of the information that Brett talks about here today. So I think that's it from my end, Brett. I'll go ahead and turn it over to you.
Awesome. Thank you, Matt, for the introduction. And it's my pleasure to be here today on the monthly webinar series. It's, down here in Ames, it's supposed to reach the low 80s. So it is absolutely a perfect time, as Matt said. Wish it was a little less windy, but, it's springtime in Iowa. So today I'm going to go over some of the checklists we created about a couple years ago, and I'm going to kind of just walk through them and give examples of what we're looking for, what that checklist is intended to do, some common challenges that we experience, and how that checklist is going to help, support getting that barn ready for the upcoming hot weather that we typically experience here in the upper Midwest during the summertime. All barns are different, so at the end of the day, parts of the checklist may not be directly applicable to you, but you'll have to use your best judgment on what parts are applicable and kind of how to do that. So what those checklists look like, there's a QR code there on the screen for you to access the checklist, or if you go to the ISU extension store and type in AE3553A, you will find the summer checklist. And then if you do AE3553B, you will also get our winter checklist. And so what this checklist does is it goes through kind of the key components of the ventilation system and cooling system that you need to get ready for the upcoming hot weather. So this includes fans, inlets, soffits, curtains, sprinklers, evaporative cooling pads, if you have them, say if you're on a sow farm, some controller settings, temperature probes, backup thermostats, and then any other notes that you may need to take. And so I'll kind of go through the different parts of this checklist. I've got some of them grouped together just for ease, but we'll kind of talk about all this in some detail. It's not an exhaustive list at the end of the day, but there's some things that might be more applicable to you. So again, use your best judgment as you kind of go through this. So I'll briefly start off just as we get into hot weather of why it's important that we really have our ventilation and cooling systems in proper working order. So when the pigs produce heat, they have to get rid of that heat in order for them to stay in their thermal neutral zone. And so they have different ways to remove that heat. And that's kind of why our ventilation systems are set up the way they are. We need to get first and foremost, we need to get the heat out of the barn, but then we also need to provide, an elevated airspeed, whether you're in a tunnel barn or a natural barn, evaporation, because once that air temperature hits in the low 80s, pigs will have to kind of find a new way to lose heat, and that's going to be mainly through evaporation of water, whether that's in the lungs from panting or if that's water applied to their skin from a sprinkler. And so what the pig really feels and experiences is really a combination of many different factors. That includes their flooring, their metabolic rate, if they're on 3 times maintenance for feed, they produce more heat, and that's more heat that they have to get rid of. The group size, how many are in that group, that stocking density. And then from the parameters that we think about for the climate inside our barns of relative humidity, airspeed, air temperature, and then the surrounding surface temperatures. So we predominantly use airspeed as our indicator of how those pigs feel, but we have to remember it's really a combined influence, and we use our ventilation system to adjust some of these factors such as airspeed and relative humidity to provide an environment where that pig can lose that heat and stay on feed and growing. So pigs' response to increasing air temperature, usually what happens is their first response is going to be to suppress their feed intake. As that pig consumes feed, it generates heat, and the last thing the pig wants to do when it's hot outside is generate more heat. So that's usually one of their first responses. So when the pig's comfortable, and what hopefully we see during the hot weather, if our ventilation system is properly functioning, they have that normal contact, their body temperature is relatively stable, they're on feed, and they're exhibiting that normal behavior where they're, got groups of them doing those different activities in the pen. As it starts to get hot, they're going to spread out. They don't want to be close to each other. And then as it gets, that air temperature approaches in that low 80s, they're going to start to find, they're going to realize that they can't lose as much heat to the air. So they're going to try to lose that heat to the floor or the concrete slats. And so that's why you'll see them shift their body positions to dump more heat into those slats. What becomes kind of interesting is those slats are still relatively cold this time of year, but as we get into those later August months, those slats do start to warm up and the pig starts to lose that ability to dump heat into the slats because that slat temperature has come up. You also see their body temperature increase and they'll start to pant because, again, they have to switch to evaporation. Again, we see that decreased feed water intake, and then they'll start to, again, find ways to increase that evaporation of heat loss by, playing in the drinkers, wallowing, trying to get moisture on their body to help, pull heat away. And as they get really hot, they'll start to pant or breathe heavier, and that's generally a pretty clear sign of heat stress conditions. So one of the things you can do to help monitor heat stress is, if you have a water meter that's connected to a controller or some sort of data logging, we see some interesting patterns. This is an example from one day in a naturally ventilated barn and a tunnel ventilated barn when they're exposed to heat stress conditions versus thermal neutral. You see the heat stress pattern kind of mimics their feeding pattern where they're going to, as they eat, they consume water, and they're going to do that in that early morning before that temperature, the outdoor temperature starts to increase. It's in the heat of the day, they're not eating, so they're not drinking. And then you see them get back on feed right during nighttime as that temperature starts to reduce. Versus in thermal neutral conditions, you see more of a one peak pattern there where they, are consistently at the feeder, at the drinker, and trying to stay on feed as they're keep eating in those thermal neutral conditions. So what can you do for your facility? For a tunnel ventilated barn, we can do things like verify how fast that air is coming in at the tunnel curtain. We can look at the airspeed in the animal zone, see if we're getting that 350, 400 feet per minute down that barn. We can look at the temperature distribution down the length of the barn. Are we seeing more than a 4 degree Fahrenheit temperature rise? If it's closer to 8, that's probably going to suggest that there's something wrong. There's a restriction, or our fan power is not enough. They might be dirty, or something else is going on, because we shouldn't see in full tunnel much more than a 4 degree temperature rise down that barn. You might see an 8 degree in that tunnel 1, tunnel 2 transition phase, but as we get into that hot weather full tunnel, shouldn't see that big of a temperature rise. So we want to check fans, belts, pulleys, variable speed control, how much opening we have, and I'll talk more about that. If you have evaporative cooling pads, is it humid outside? What's our pad face velocity? If it's a worn out, clogged, calcified pad, you're going to start to see it restrict, and you're going to start to get a much lower than that 350 feet per minute that we're looking for. Plus, we need to check our water pumps, nozzle pressure, distribution bar, and make sure all that's in working order. If you have a sprinkler system, we want to verify the coverage area. Are we able to get that 2/3 pen coverage? Can the pigs get to it? Is it distributing, that large droplet, low pressure, or is it more of a mist? Or if you're missing a nozzle and it's just a straight jet down, shooting down, what's your sprinkler on temperature? Is it too high, too low? You can do things like measure the water that comes out of the sprinkler on that 1 to 2 minute interval to see if you're getting enough water to that pen. So as we move into late spring, early summer, I really want to emphasize that we need to check that all that equipment is working. Manually flip switches because they may have been switched off, so we can, if you flip the switch at the controller and the fan doesn't work, is it still off on the wall? Just to make sure nothing's happened since they've been, tunnel fans, for example, have been dormant for the last 5 or 6 months, 4 or 5 months. We want to make sure those curtains open. We want to make sure that solenoids work. But really manually testing them and verifying that they work before you're in the situation where the controller calls for it and there's some malfunction somewhere else in the system, because the controller can only do its best to operate, but you have to make sure that that equipment actually functions. It's always good to take a review of the settings. What should your set point be? Is your growth curve on? Do you make adjustments for a summer versus winter temperature? Some people tend to decrease by 1 or 2 degrees on set point in summer because everything around the pig is warm. Fan differentials should be closer to about 1/2 to 1 degree between stages. Look at your total differential. Usually we stretch that out a little bit in winter. It should be somewhere around that 8 degrees, 6 to 8 degrees Fahrenheit for that total bandwidth during the summertime. So we got to go through and check on temperatures for stir fans, sprinklers, pads, etc. And on pads, take a look at them. Do they need to be replaced, descaled? Try to figure out do we need to, as that pad scales, it becomes more of a restriction, which is going to add static pressure, which reduces your total ventilation rate by adding restrictions to the fan. So keep that in mind, make sure the pumps work and you're getting good distribution and avoiding streaking. Watch the pigs, watch their behavior, lying patterns, and have some form of a measurement, whether it's quantitative or qualitative, but take a look and try to assess the situation. Common tools that we often use, generally these are mainly more on the minimum cold weather ventilation side, but there's also some applicability during the hot weather. I always like to have a portable weather meter to measure temperature, humidity, and airspeed. That's how we typically verify airspeed at the inlet. We also can use it to verify airspeed during tunnel or at the tunnel opening to see what kind of airspeeds we're getting. Smoke sticks, usually not too important in summertime. Tape measure as well. Static pressure is always good to know to see what we're pulling on the barn. Laser tachometer is useful for measuring fan RPMs, because if you know what it should be doing for that pulley arrangement and the motor, it's worth comparing back to what the manufacturer says. Volt or multimeter for checking connections and for fans. And then gas detection tubes, usually at our high ventilation rates, we don't worry so much about ammonia inside the barn or carbon dioxide because we're changing that air over so frequently. So let's dive into fans and what we should be looking for. So before we get into fans, we need to make sure we first do this. We need to remove that plastic. I know it's supposed to cool off a little bit next week, but we're getting to that point where we're about 50 degrees outside, where we can probably safely assume that we can take that plastic down. It does a great job at minimizing infiltration during the winter, but as we get to summer, we obviously need to make sure that those fans have the ability to operate. Also a good time to clean those fans. If they haven't been cleaned before or accumulated any dust or dirt, let's get those cleaned, because we're going to be relying on those pretty heavily during the summertime. Also, if you have any snow damage or snow removal damage, it's time to get those cones replaced, because those cones add about 15% airflow to those fans by kind of helping reduce the drag or the turbulence coming out of those fans. And it's also a great time to check belts and pulleys. Right, so as those fans get dirty, or there's restrictions, or we don't have enough open area, that causes an increase of static pressure or resistance on that fan that the fan must work against. And so as that restriction increases, the airflow that fan's able to exhaust is going to decrease. And so if we have less airflow through the fans, we might have less air exchange in the building, which would result in lower tunnel air speeds, or that barn getting a little bit too warm too quickly, and jumping to the next stage too fast. So it's important that we, make sure those fans are clean, belts are tight, everything's good, to minimize how much restriction that fan is going to have to work against. So need to make sure then throughout the summer, we're routinely cleaning fan shutters and blades. It's simple. If it's more caked on, it might take some more manual with a broom, or you can usually just hit them and the dust will fall off. But you can kind of see there, fan A, is experiencing probably, minimal restriction. The shutters are hanging nicely, versus fan B is having a lot of restrictions, probably from like a loose belt where it's just not able to pull that air. Dirty shutters can really significantly reduce performance. You can kind of see in the pictures on the right, how much restriction that extra weight of those shutters, that the fan has to work against, and why keeping them clean is quite important. Again, here's another example. As you're walking around your barn, and if you're in those tunnel stages, take a look at your fans. Both those fans are operating, but you can clearly see a difference in what those shutters look like. So this is an easy and kind of telltale sign that you probably have a worn belt or a worn pulley, that fan is just not able to generate the power to really operate correctly and pull air down that barn. Versus that fan on the right, it's nice and open, the shutters aren't flapping, and good indication that fan's in pretty good working order. The other thing is, you probably also assume that the fan on the left is probably in tunnel 1, since it's being used a lot more frequently than the fan that's probably in either tunnel 2, tunnel 3. So pay more attention to those fans that are going to operate, or have those fans rotate a little bit just to even out the wear across those different fans. So the effect of the belt is quite significant. So the graph on the right shows, static pressure across the fan versus the airflow that fan can produce. The pink line is the belt before it was tightened and adjusted. As you can see, it reduced the airflow performance by about 15-20%. And then you also can see that line's a lot steeper, meaning that as we have a little bit more restriction, as we're in tunnel or tunnel 1, that fan's even going to move less air compared to with a tight belt, new belt. The fan performs much better, and it's a much flatter line. And so that what happens is that belt wears, it reduces that fan RPM, and that's why it cannot provide as much airflow. Again, what to look for on pulleys. If you see that belt sunk down, it should be just slightly above the edge of the pulley. An old belt's going to be down. You see the edges of the pulley. Or if you see that pulley rounded out, that's usually a pretty good indication of worn out belts on the fan. And so, when you lose a little bit of RPM, just because of that pulley being a little bit smaller diameter, you can lose up to, somewhere between 15 to 25% of the airflow of that fan due to the wear and tear on the belts and pulleys. Another thing to check for is your motor alignment. This is what's going to lead to that premature wear on the belts and pulleys. We run them in a nice straight line. If they get offset a little bit or angled, that's going to lead to much more fast wear, and then having to change out belt and pulleys a little bit more frequently. So we want to keep proper alignment, inspect them, take a look. It's generally pretty easy to do. And then again, if you see a fans like in the previous picture where one's just not performing well, it's most likely due to a worn out belt and pulley. Let's talk about inlets a little bit. I know in summertime we don't quite use them, but our nighttime still get kind of down to the point where we still have to switch a little bit in and out of using our power ventilation before we go to tunnel or drop the curtains. So it's also a good time to inspect inlets, because again, we still do have to use them. Repair any inlets, make sure they're in good working order. They're sealed, they're hung, they're tight to the ceiling. We don't want any gaps, because all that's going to do is lead to poor air distribution, especially when we're operating at a little bit of that higher CFM, where we need to get that fresh air through the barn, because it's a little bit warmer outside than compared to wintertime, where it's much significantly cooler. So take the time to go through, tighten, calibrate, and make sure they all open uniformly. run the actuator close first, tighten them up, make sure they're all the same. Repair if needed, run your actuator. If it has an auto calibrate, it's convenient because it can do the timing for you. If not, run the cycle yourself and figure out what your runtime, your open and close run times are, and make sure you get that updated in the controller. Cables and ropes stretch over time, and so it's a good time to check those things and make sure they're in good working order. Another thing to do is check your limit switches. So this is on a standard current machine, go through to make sure those are operating correctly. You've got those set to make sure everything can fully close and fully open. So if it's on your tunnel curtain or sidewall curtains or your inlets, we want to make sure that those are set correctly so that we're not either going too far or not enough, and making sure things are operating in their full range in which they were originally intended to do. Let's talk a little bit about curtains, soffits, and sensors. So again, repair and patch holes in curtains. Now that the weather's a little bit nicer, it's a little bit more fun to do versus trying to do this in the dead of winter. So if we can get this done now, it's going to be a lot better when we get to winter, later this year, because all those holes are just letting cold air in and really impeding good air distribution during the colder months. So take the time to go through and patch those curtains, to make sure that when they're going to spend a lot of the time down, that we get bait in them, just because they become good trails for mice. And so we want to use this opportunity to make sure we get the rodent station set up or put bait in them, because they're going to be down, for a significant amount of time during the warmer weather. Again, check ropes, cables, sags, actuators, limit switches for these. And we want to make sure everything is snug and connected properly, so we can make sure that curtain can come all the way down, and not leave any parts up that's going to impede airflow or wind going through that barn. So, checking, we should have at least like a 3-inch overlap on the curtain. If there's a sag, there's not enough overlap in that top left picture, that's all the way closed. Again, maybe not a huge deal in summertime, but something to fix now, and check again right before winter to make sure we get a good overlap and we're not just letting cold air coming into that barn. Check your cables and pulleys. You can see there on the right that that's clearly been disconnected, so that curtain's probably not going to function that great, or it's going to just cause problems and wear more and cause other components to wear. That's going to result in potentially a poorly ventilated barn. Also, make sure the soffits are clean. We still do use our inlets in summer to some extent, not as much as in winter, but take the time to make sure those soffits are unclogged, because that's going to be a restriction. If we restrict air there, it's going to lead to not enough air going through the inlets and that barn getting too warm too quickly. They need to be free of debris to really effectively let that air up into the attic. So when we're in that transition that we're at somewhere between 40 to 60,000 CFM through the attic, we need to make sure we're able to get that air in there and we're not causing any sort of restriction in the barn. It's also a good time to check insulation stops, as those tend to move over time. It's a lot more fun to go in the attic and check those when it's warmer outside, not so fun in the winter. So it's always a good time to check those and make sure they haven't gone too close to the roof and are causing some sort of a blockage or restriction that would inhibit air from coming through the soffit and into the attic. Another thing, if we have restrictions in the soffit or somewhere else, it can lead to, that current hanging up, right? So here's an example of, a really high static pressure because we're not pulling enough air in through the inlets. So that's causing that curtain to get sucked in tight and then kind of rolling over itself and not really actually being able to drop fully open. So to fix this, we have to make sure we get our timing and staging correctly. So we allow that curtain to open, before we have a lot of tunnel fans on, or else you're going to create too high of a static pressure because that open's not wide enough to let all that air from those tunnel fans pulling through that barn. The same thing can happen on a natural barn. If you're right in that transition before the curtains drop and the soffits are choked or the inlets are shut, that current's not going to be able to go down because we're pulling air. That becomes the path of least resistance to that crack, and that current's going to hang up and not be able to fully drop, or even potentially not drop at all, resulting in maybe that barn getting far too warm. Easy way to tell if you got your curtains right and there's still something else wrong. If that door slams shut, there should always be a slight pull, right? It's a negative pressure system, so we're pulling air in and exhausting it. So if that door is slamming shut, that's usually a really good indicator that the static pressure is too high and we have a restriction somewhere else in the system. So it might be at the soffit, it might be the insulation stop, might be the inlets themselves. So that door becomes the path of least resistance for that air to come in. So we want to make sure we take a look at that. Also, it's a good time to verify sensor location and management, clean the probes, because especially in all year, the controller relies on information from those temperature probes. And if it gets bad information, it's going to make decisions that we don't want. So this is an example of what happens when you clean the probes. You can see it's changed the temperature quite a bit. So it's important, wipe those probes down, make sure they're in a good spot, make sure they're not, especially if you have sprinklers, make sure they're not getting directly wet, because that's going to cool that temperature probe off way too quickly and cause that barn to start to do things quicker than we would like it. Also, and then always good practice is make sure they're not in front of heaters or directly in front of inlets. Just again, it can cause the controller to do things that we don't want it to do. All right, a little bit on sprinklers. So the goal of sprinklers is to provide water to the skin of the pig. That water is going to evaporate, and then it directly pulls heat from the pig as that water changes from a liquid to a vapor. And so we want to make sure we get the pigs properly wet, and then we allow time for that water to dry. The wetting of the pigs doesn't exactly do the cooling. It's really the evaporation time, that interval where the sprinklers are not operating is when we're actually removing heat from the pig. So I usually recommend somewhere in the low 80s as an on temperature for sprinklers. And typically they need to be about 100 pounds or heavier. You could also do it as a offset from the set point, which then is usually about 16 to 20 degrees from whatever your set point is. And typically you can use somewhere between 1 to 2 minutes is pretty common. If you're potentially in a drier climate, like in Arizona, California, you could maybe use a little bit longer time, and also a much shorter interval dry time, just because that dry climate is going to evaporate water much more quickly. So we don't want to continually wet. That's going to cause the relative humidity inside the barn to rise, because we just added all this moisture and water that's going to evaporate. And then our ability to actually evaporate the water that we want to from the pigs also is going to go down. And so typically in natural barns, we'll see more of a cone nozzle. Tunnel barns tend to be a flat or a spinning nozzle. We want to keep those parallel to that airflow. So the infrared picture there kind of shows a pig with its back wet. You can see how that's a much cooler, because it's evaporating. It's decreased that temperature, which is removing heat from the pig. And then as that water dries, you can see that the skin temperature comes back up to where it was before. Another example of this is, again, the barn on the right the picture on the left prior to sprinkling. And then you can kind of see how that water distribution, covers a lot of the pigs. You can see how they're much cooler with that water evaporating, cooling that skin temperature down. It's somewhere about 10-ish degrees cooler with water when it's evaporating. So again, that drying is what's removing the heat from the pigs. So inspect and test your sprinkler systems. Make sure the water is on, those valves are turned, the solenoid works. We clean any water filters. Again, anything that's going to inhibit that water flow, you might not get as much water to the pigs, or the pressure won't be enough to actually get the pen coverage that you were looking for. So we want to make sure your filters are clean, everything's operational, our nozzles are clean and properly distributing water. Replace any missing nozzles, because if there's no nozzle, that water just shoots out, and it's not really, it becomes more of enrichment and the pigs enjoy it, but it's not really dispersing water to their skin that's going to provide the cooling we need to keep them out of heat stress conditions. And then just kind of paired up with sprinklers, if it's in more of a natural barn with stir fans, we typically want to turn those on before the sprinkler temperature, because when we add airspeed with water on the back of the pigs, that's how we really increase that evaporation rate and pull even more heat from the pig. So we want to start with fans, maximize how much heat we can pull by moving air over them, and then add the water with the high rate of evaporation to really cool those pigs off. So for example, that'd be somewhere between about 75, 78 degrees, and then you'd have your sprinklers come on somewhere around, low 80s, 82 to 85, and that makes a good combination to maximize how much heat we can pull from the pigs. So ideally, we want to, if we're using them for supplemental cooling, we want to, point those down at the pigs. In wintertime, we tend to keep them parallel because we don't necessarily want to draft them with cooler air. So in summertime, when that air temperature is much warmer, we can directly point those fans at the pigs, and it kind of creates, a tunnel barn, or simulating that wind blowing over those pigs. All right, evaporative pads. A lot of finishing does not use them, but for those in sow farms with evaporative pads, a little bit on this. So the goal of the evaporative pad is to evaporate water that's absorbed into the media. And as that water evaporates, and this is very similar to how it works on the pig, just applied to the media. So that water evaporates, it removes the heat from the water, the pad material, which cools off the air coming in. As a result, as water evaporates, it's going to add moisture. So as that air flows through at a warm, dry humidity, it's going to come out with a cooler temperature, but added moisture to it. And so the limits of the evaporative pad is really whatever the outside conditions are doing. So when it's really humid outside, you get less cooling. If it's really dry outside, you get a lot more cooling potential. So the chart on the right kind of shows the potential of how much cooling you can get, and this explains it a little bit better. So we'll typically see the temperature coming out of the pad decrease until the relative humidity outside is about 80 to 85%. So that's our typical mornings throughout the summertime here in the upper Midwest. And during the day, we typically see humidity somewhere between 45 and 65%, even when it's 80 some odd degrees outside. And so when it's humid air, so like in the mornings, we'll probably only see about a 5-degree-ish temperature decrease. When it's relatively dry in the middle of the day, we might see up to 10 to 15 degree decrease in that incoming air temperature out of the pads. And so the chart on the right shows the relationship between outside temperature, outside relative humidity, and the incoming air temperature into the barn after it's gone through the pad. So you can see, you might only have a few degrees. And if you look in the upper half of that chart, which would be typical morning, down the upper left, it would be typical morning. And then our daytime is somewhere in the bottom left, bottom middle. And, you can get up to 10 to 15 degrees of cooling during summertime. Now, one of the questions that also comes up is, when do you turn those pads on? When you hit maximum ventilation, a minimum outside temperature, a minimum outside relative humidity. You anticipate it and wait for the pads to get fully wet. It does take about a half hour or so to actually completely soak those pads. It also takes at least an hour or two for those pads to actually fully dry out. So even once you stop using water, those pads are still going to produce some cooling until that paper media fully dries out. So here's a kind of an example. If you're using evaporative pads, kind of how it happens. As outside temperature increases, the outside relative humidity decreases, and that's because as air gets warmer, it's able to hold more moisture, and so that humidity decreases during the hottest parts of the day. But really, the amount of moisture in the air stays relatively the same because relative humidity is relative to whatever air temperature it is at. And so we see the same thing with the pad. As that pad comes on, we see the temperature go down, but that moisture goes up as we're adding water to that incoming air. So there's a lot of common challenges with pads, water distribution with the spray bar, could lead to streaking. So we want to make sure that we get a good uniform distribution. because if that pad's not wet, it's not producing any cooling. We also want to make sure all of the air coming into that barn is going through the pad and not through inlets and the pad, because again, you don't want to mix warm outside air with cool, moist air from the pad. So we want to force all that air through the pad, and we want to make sure that pad is fully wet everywhere. We also see that pads over time, as that water evaporates, it leaves minerals in the water. And so those minerals eventually get deposited on the pad. And so we need to descale those and keep those pads clean so we can effectively pull air through them. So we want to make sure that we're, flushing the inline strainer, bleeding off some water once in a while, checking for streaking, check valves, control sensors, distribution pipe, check the sump, check the float valve, and just make sure we keep our pads in proper working order. So the image in the bottom middle there shows the example of an old calcified pad where it's really hard to pull air through it versus you replace it with a new pad, really increases how much air you can go through there because it's less restrictive on the fans, and then those fans can perform a lot better. So some, again, key points. This is repeat of the slides before, but I think it's, again, really important that we take the time to do these things and really make sure all equipment's working, because if you don't and the controller needs it, it's not gonna happen. The controller can't fix broken equipment, can't fix loose belts. So we need to make sure we go through as humans and check that stuff and perform the necessary maintenance we need to do to make sure that ventilation system is properly functioning. Again, review settings, make sure if we use a winter schedule with different differentials and staging, we get that transferred over to summer. That's sometimes why I don't like recommending using spring and summer or winter and summer settings, just because it requires somebody to go through and change them. And that's, hit or miss if that actually gets done. So if we do that, let's make sure, now is the time to start checking that, check the on temperatures, and just go through that controller and make sure it's set up the way we want it. Again, we just went through evaporative pads, but take the time to inspect it, turn it on, do a test run, make sure everything's clean, flowing nicely, and those pads are in good shape. And as we go through the barn in summer, watch the pigs before they get disturbed when you walk in the barn, see what they're doing, see how they're lying. Are they all down? Or do you have a mix, some at the feeder, some drinking, some lying, some walking around? You should see that good mix of behavior. If they're all down lying, they're probably hot, indicating that barn's a little warm, and maybe take a look at that ventilation system and see, is there some opportunity there why that barn's too warm? So always use those pigs as feedback and make the necessary measurements, whether it's, using one of the tools I listed earlier or just using your eyes and hands to inspect things. You won't know until you take a look at stuff and really dive deep into the maintenance and equipment and getting your barn ready for the upcoming summer. So with that, I'd be happy to take any questions. Thank you.
Thank you, Brett. Just a reminder to the audience, if you've got any questions, feel free to go ahead and put those in the chat in the bottom right portion of your screen. We do have a few to go over, so I'll start us off, Brett. We talk about sprinklers. And typically when we want to talk about flow rate at the drinker, we're looking at 1 to 2 cups per minute for nursery pigs, 2 to 4 cups per minute for grow finish pigs. Is there a benchmark flow rate that we should look to target at the sprinkler, or is it more important that we just look at in the given time that they're on, that we target that the pen's getting wet and that our spray pattern is sufficient?
Yeah, I'd probably focus more on the spray pattern and that the pens are getting sufficiently wet. So if you happen to have an empty pen, this works really well. Turn the sprinklers on and just see if that's enough to fully wet the slats. So if you're on too short, you might still see some dry spots on the slats. And then what to do is, so you run it for 2 minutes, see how well you coat the slats, and then turn it off, and then kind of wait to see how long it takes the slats to dry. It might take a little bit longer than what a pig would do, but it kind of gives you an indication of, how well is this working? Am I fully wetting those slats before I turn the water off, or do I still have some dry spots on those slats after that 1 to 2 minute period. Everybody kind of uses a little bit different on time. But I believe the recommendation on sprinkler flow rate is around like 1 to 2 gallons per minute from a nozzle. I might have to double check that one, but I believe it's somewhere around there.
Mm-hmm. Another question we've got here. What products are available to descale evaporative pads? Or is it more or less just, I guess maybe is there preventative maintenance that you can do to help prevent scaling? I'd add that in there as well.
Yeah, so preventative maintenance, the best way to do that is to bleed off water. I know that doesn't sit well with a lot of people because that water just runs off onto the ground and it seems like a waste, but that's really the best way to get rid of those that mineral concentration that builds up in the sump when running pads. But there is numerous commercially available descalers. If you look at whatever brand pad you have, they actually have they have very different recommendations each. The main one is don't use like bleach or chlorine, but they do have some different products out there that you can use on those pads.
So it's more pad manufacturer recommendations on that.
Yep.
Another question we've got: what would be a drawback to using a sock on the exhaust side of the fan and removing the shutters during the summer months?
So a sock with no shutters. That's better than a sock with shutters. That sock, is going to reduce the airflow from that fan by probably 15 to 20%, somewhere in there. Shutters too probably restrict airflow by maybe about 10%, just because even, perfectly clean brand new shutter is still going to have some restriction. So, assuming if you're using a sock, you're probably on potentially a filtered farm. So if you can be okay with not having the double backdraft protection with removing that shutter, because if that fan fails, which most fans all fail at some point in their life, then you have nothing, the shutter to basically block any from air coming back in, but hopefully the sock seals up tight and blocks any of that air from coming back in that barn.
Excellent. I don't see any more questions at this time. We'll maybe give another minute for folks to go ahead and quick submit something if they've got something they want to learn more about, or have Brett answer while we've got him. But Brett, I do want to thank you for joining us for this month. We got one more question. Brett, could you comment? Oh, hold on. Comment on the use of cellulose versus plastic cooling pads.
So yeah, usually that paper cellulose media is probably the most common. Plastic pads are becoming, I think, a little bit increasingly popular. So one of the benefits of plastic pads is they don't scale as easily as paper pads, and you can also hit them with a pressure washer, which you cannot do with most paper pads. The drawback on plastic pads is they don't produce quite as efficient cooling as a paper pad does. It's a lot harder to get the water to right. It can't absorb into the plastic, so the lattice structure has to be able to hold those water molecules that produce that cooling. So it tends to go through quicker. So they tend to be a little bit less efficient, but I think there's been some newer designs in plastic pad material or plastic pad structures that have gotten really close to the same cooling efficiency, it's at the same face velocity as a paper pad. So usually the times I recommend plastic pads are if you're in a really, really poor water quality area and you're stuck replacing your pads, you're getting less than 3 years of lifespan out of them. It might be worth the investment in the plastic pads, just so you're not constantly replacing those pads because they're getting calcified way too quick. But usually plastic's good for some pretty poor and hard water areas.
Excellent. Brett, I want to thank you for joining us for this month. And again, for all attendees, to go back and review this information, or if there's anything you want to refresh on, this will be posted to the Iowa Pork Industry Center's YouTube page. So with that, thank you again, Brett, and reach out to any of us at IPIC if you have any questions in the future.
Awesome. Thanks, Matt. And thank you all for your attention. Have a good weekend.